Consider a cuboid, all of whose edges are integers and whose base is a square. Suppose the sum of all its edges is numerically equal to sum of the areas of all its 6 faces. The sum of all its edges is. So, I have drawn a figure here. Let's call the length of the base as L and height as H, where L and H are positive integers. Now, statement from the problem says 8L plus 4H, that is the sum of all its edges, equal to 2L square plus 4LH, that is the area, sum of the areas of all its 6 faces. Now, the problem is we have just one equation, there are no other conditions given, but we have to solve for two unknowns L and H. So let's try to manipulate these equations a little bit. So I get H as 4L minus L squared by 2 into L minus 1 after cancelling of 2. Now, since L minus 1 is greater than 0, we should have 4L minus L square greater than 0. So that means L square minus 4L, that is L into L minus 4, should be less than 0. So when you solve this inequality on the number line, I get L values between 0 and 4. The L value should lie between 0 and 4. And of course, between 0 and 4, the possible L values are 1, 2 and 3. But we have already eliminated L is equal to 1. L is equal to 1 is not possible. Why? Because when you have L is equal to 1, this condition says 4H is equal to 4H does not give any other meaning. So we have L between 0 and 4. The possible integer values are 1, 2, 3. 1 is already eliminated. So we are left with two possibilities, L is equal to 2 and L is equal to 3. Now let's check with both the cases. When you put L is equal to 3 in the expression for H comes out to be 12 minus 9 divided by 4, which is 3 by 4, which is not possible because it's not an integer. When you put L is equal to 2, we have 8 minus 4 divided by 2 equal to H. So that is equal to 2. So that is the only possible value of H. So the only possibilities are is H is equal to 2 and L is equal to 2. And we need to find the sum of the we have to find the sum of the edges. Sum of the edges will be 8L plus 4H, that will be 24. So the answer is option C.